Alright, welcome guys, and thanks to Mr. Howard for being here today and helping you through this section 8.1 on probability and the sample space. We're going to start by exploring two questions to help us get a handle on this probability. First one is, what's the probability of getting a head and a 6 when tossing a coin and rolling a die? And shorthand for that is, what's the probability of getting heads and a 6? And the second question is, what's the probability of getting a head and an even number, or probability of head and even number? So in order to do this, in order to calculate these probabilities, we're going to use tree diagrams to list all the possible outcomes for the experiment of tossing the coin and rolling the die, and to determine the probability of each of the two events. The event of getting heads and 6, or the event of getting heads and an even number. So we're going to go ahead and draw a tree diagram, and we do that by setting out that we're going to, first thing we're going to do is toss a coin. So we could have heads or we could have tails. Notice that I didn't start that right at the top of my empty space up here, but a ways down, because I know that from the heads, once I toss the head, I'm going to roll the die, and I'm going to have 6 options there. I could get a 1, a 2, a 3, a 4, a 5, or a 6. And from my tails, I could have a 1, a 2, a 3, 4, 5, or 6. So this tree diagram shows my experiment. I tossed a coin, which was represented here, and I rolled a die, which was represented in the right-hand set. All of my outcomes are heads and a 1, heads and a 2, heads and a 3, and so on down the line until I have tails 5 and tails 6. So you can see that you've got 12 outcomes here. And these 12 outcomes are called the sample space. The total of all the outcomes is the sample space. Now, our first event was to get a heads and a 6, and we can see that that happens here. The second event was to get heads and an even number, and that happens here. Heads 2, heads 4, and also heads 6. So based on our tree diagram, we can see that the theoretical probability of an event happening, where each outcome is equally likely, any of these could happen, is like this. The probability of the event is equal to the number of outcomes for the event divided by the number of outcomes in the sample space. So for us, the probability of getting a heads and a 6 is 1 out of 12, and the probability of getting a heads and even is 3 out of 12. We should probably also note here that as far as the sample space is concerned, the sample space is always equal to the product of the number of outcomes of the two parts, or the parts of the experiment. So in this case, we were tossing a coin that has 2 outcomes. We're rolling a die that has 6 outcomes, so our sample space was 2 times 6, or 12. And we can see that here, the 12 outcomes in the sample space. So if you know that heads and 6 can only happen once, then you can calculate that the probability of heads and 6 is 1 out of that sample space of 12, even without doing the tree diagram. Or if you